Hello and welcome to the very last part. So we're just going to have a quick look at a couple of more theoretical questions. So this theoretical question was literally asked last year on the exam. So basically what's the goal of this question, which is question number 5, is they kind of construct a very general function that would respect this thing. And for this, we mainly expect you to look at some of the characteristics. So one of the characteristics here that you should immediately notice is that there is a root there, and it's not a simple root. Well, it should be an even root because you see, well, this function goes down and then immediately goes up. So this is an even root there. And then some other things that are notable as well. Well, basically we have a vertical asymptote here. And then we have another vertical asymptote here, and we have another vertical asymptote over here. So that means we have at least 3 vertical asymptotes. So what do we already know? Well, we can already say that our denominator needs to have something that looks like this, right? It needs to be at least raised to the power of 3. Right? So I fill it in by a very general polynomial. It's, of course, it doesn't need to fit exactly, but just to get a very general idea. Now, there is another thing that we know. Well, if you look at this, well, you can already notice that there is also something else. There is this line here that I can draw to it that the function clearly tends towards. This is the oblique asymptote. Of course, the line which should be a bit more up, but basically there is an oblique asymptote here. When do you get an oblique asymptote? Well, when the degree of the numerator is equal to the degree of the denominator plus 1, right? So it needs to be 1 higher. So that means this needs to be at least x to the power of 4. But we need to be careful here because, well, here at 0 there was at least a double root. So how can we write it? Well, we already know that it's going to be x squared times, and then we need to make sure that we don't go over x to the power of 4, and then we can just write, well, we started at d, so we can say fx squared plus gx plus h. And this would be a very general way of writing this function. Of course, you need to be careful when f and g and h, maybe things cancel out, but this is basically what we want you to think about. We want you to see that this function has a couple of characteristics that tells you something about it. So we want you to really pay attention to all of these things. And then the other thing, well, that's also still important once you have that is, well, what's the sign of this function? And of course, if you just write a, and a can be an element of R, it does, of course, doesn't really matter. But if you say, well, it's only a positive number, so you allow it in there, well, you need to be careful, like, how does it start? And then you need to have a look at the general shape of the function, right? So if you look at this thing here, you want to make sure that here you have something cup-shaped, so that it comes down and then it goes up. So how would that be? Well, this x squared, well, it needs to be positive. Okay. All of that being said, that for exercise 5. Exercise 4 and 6, I strongly recommend that you think about those ones at home. Basically, don't make it too complicated. 4, look at the roots, and 6, think, oh, what clever solution could there be? So what function already has a local maximum and x is equal to 0? And how can you introduce a vertical asymptote to that? Okay, I know that was a lot. That's it for exercise series number 9. Bye-bye.